Wisdom Bites. Subscribe to one dose of wisdom at a time.
Did you shoot off a quick email? Maybe scroll through some photos on your phone? Did you stream a video or, I don't know, walk past a doorbell camera while you were grabbing the mail?
It all sounds so mundane when you list it out like that, doesn't it? Just, life happening.
Exactly. But if you look at it through a different lens, you were leaving a trail. We are all walking data generators. We are generating terabytes of this stuff every single day. But here is the problem, and it is a big one. Most of that data, something like 95% of it, is what they call unstructured data.
Which is a very polite way of saying it's a total mess.
It is a complete garble. It's not these nice, neat numbers in a spreadsheet. It's photos, it's voice memos, it's erratic clicking patterns, it's the shaky video of your dog. It's just noise. And for a long time, traditional computing just looked at that and, well, it shrugged. Could he do anything with it?
Right. It's just digital exhaust. It just sort of drifted away. But that is exactly where machine learning, or ML, enters the chat. It's the tool, maybe the only tool, that can look at that chaotic, messy pile of noise and actually find a pattern. And more importantly, use those patterns to make predictions.
And that is exactly what we're unpacking today. We are diving into this fascinating book called Big Data, Big Design by Helen Armstrong. And the mission here is pretty specific. We aren't just geeking out on the code or the engineering side of things. We're looking at why designers, the people who actually care about the human experience, need to take the wheel of artificial intelligence.
It's a critical argument. Armstrong basically says that if we leave AI entirely to the engineers, we might build a future that's incredibly efficient, sure, but completely uninhabitable for actual human beings.
So the vibe we're going for today is looking at AI not as some robot overlords, but as a design material, which is a weird concept to me. I think of wood or cardboard or plastic as materials, not algorithms.
It really requires a mental shift. We're moving from the old era of computing, which was all logic-based instructions, basically telling the computer, step one, do this, step two, do that, to what we have now, these prediction machines. You don't tell it the rules anymore. You just show it examples, and it figures out the rules for itself.
Okay, so let's get into the nature of this beast then. If we're going to treat ML like wood or clay, we need to know how it behaves. How does it actually work in practice?
At its absolute core, ML uses historical data to predict future outcomes. It's a prediction machine. And there's this wonderful analogy in the source material from artists Mimi Musso and Diana J. Nusra that I think just nails this. They compare machine learning to salt.
Salt, like table salt.
Think about it. On its own, a pile of salt is, honestly, pretty boring. You aren't going to sit there and eat a spoonful of it. It has almost no value in isolation.
I mean, maybe if you're really desperate, but yeah, generally no.
Exactly. Yeah. But when you add it to a meal, even just a little bit, it completely transforms the flavor. ML's like that. It's an ingredient. It's rarely the product itself. It's the additive. If you're watching a baseball game, the game is the product. But suddenly a stat pops up predicting the batter has an 80% chance of striking out. That salt changes how you experience the game. It adds tension. It changes the flavor of reality.
I love that. It's a flavor enhancer for the world. But
Yeah.
the book also brings up this massive economic point that I found really striking. It compares the rise of AI to the drop in the cost of artificial light back in the 1800s.
And this is such a vital comparison for understanding the scale of what's happening. Back in the early 1800s, artificial light, candles, oil lamps, it was expensive, a luxury. But then the cost just plummeted. And when the cost of light dropped, it didn't just mean we had cheaper candles, it changed everything.
It wasn't just about seeing in the dark anymore.
No, not at all. It changed architecture. We could build huge rooms with no windows. It changed the economy. We invented the night shift. It even changed our biology. We stopped sleeping just because the sun went down. Cheap light completely restructured society.
And the argument here is that cheap prediction is going to do the same thing.
Precisely. Right now, prediction can be expensive. If you want to predict if you have a disease, you need a doctor. If you want to predict if a business strategy will work, you need a whole team of analysts. But ML makes prediction cheap and abundant. And when something becomes cheap, you start using it for everything.
So we're going to start predicting everything, from how we shop to how we drive.
Everything.
Yeah.
But, and this is the big but that the book really hinges on, who is deciding how that prediction gets used? Because if you just let the math decide, you run into some serious problems.
Which I think leads us to my favorite analogy in the whole book, the dinner party. This just perfectly illustrates the tension between the data scientist and the designer.
It's such a great visual. Okay, so imagine you're throwing a dinner party. If a data scientist is in charge, they start by looking at the available ingredients. They look at the data. Okay, we have 50 pounds of potatoes and a gallon of milk. It is most efficient to serve everyone mashed potatoes.
Right, it's totally optimized. I have the data, here is the output.
Exactly. But the designer starts with the guests. Who's coming? Are they vegetarian? Do they have allergies? Is it a hot summer night where nobody wants heavy mashed potatoes? The designer looks at the human need first and then finds the ingredients to make it happen.
And the key insight here is that if we leave AI entirely to the data scientists, we get optimized meals that no one wants to eat.
You get efficiency without empathy. And that is why designers have to get involved. We need someone to look at the guests before we just start cooking.
So let's talk about what it looks like when designers do get involved, because we're already seeing this. The book talks a lot about anticipatory design. This is where the system knows what you want before you even ask for it.
And we are seeing this everywhere now. Think about something like Stitch Fix. It's a service that combines algorithms with human stylists. It uses data to predict what clothes you'll like, but it keeps a human in the loop to understand the context that the data might miss.
Or even McDonald's. I actually didn't realize this until I read the book, but they're rolling out digital menus that change based on the weather or even the specific car pulling up.
It's hyper-personalization. If it's raining and cold, the menu might highlight comfort food and coffee. If it's a hot afternoon, it pushes ice cream. There was another great example from some students at North Carolina State who prototyped a predictive maintenance app for cars.
Oh, the one that scans the car in the parking lot?
Yes. So imagine this. You drive into the parking lot of an auto parts store. Cameras scan your car, identify the make and model, maybe even hear the engine. Before you even walk through the door, the system has predicted what you probably need, maybe a new headlight bulb or an oil filter, and it's ready for you.
It just removes the friction. You don't have to look up the part number in that giant book that's always chained to the shelf.
Exactly. But there's a hurdle here, isn't there? The book calls it the cold start problem.
Ah, the awkward phase.
It is. ML systems are kind of like toddlers. When you first start using them, they don't know you yet. They're clumsy. They make really bad guesses.
You bought a toilet seat once, so you must be a collector of toilet seats.
Exactly. And the design challenge is, how do you keep the user engaged while the system is still stupid? You have to design for that learning curve. You have to manage expectations so the user doesn't just get frustrated and quit before the system gets smart.
But let's flip that coin. What happens when the system gets too smart? Because we can't talk about this without looking at the potential downsides. If the system is predicting everything I want, am I really making my own choices anymore?
This is the big warning from Eli Pariser about filter bubbles. We used to have human editors deciding what news we saw. Now we have algorithms. And if the algorithm only shows you what it predicts you will like or what you will agree with, you end up in a web of one.
The experience bubble.
You're completely isolated in your own personalized reality. And it raises that huge question of agency. Do I want the machine to do it for me, or do I want to do it myself?
It's the automation debate. It's convenient, sure. I mean, I like that my music app knows what I want to hear next. But at a certain point, am I just a passenger?
That is the balance. As these systems get better at anticipating our needs, we risk becoming passive. Designers have to balance that convenience with user control. They have to give us the ability to steer the ship, even if the autopilot is really, really good.
Oh, okay, so we know we need designers to get involved to solve these problems. But the book highlights a really practical issue. Designers don't know how to use this stuff. You can't just hand a designer a block of machine learning and say, here, sketch with this.
Right. It's not like clay. John Zimmerman from Carnegie Mellon talks about this. If you give a design student a piece of cardboard, they can cut it, fold it, tape it. They learn what the material does by playing with it. But ML is invisible. It's just math in a black box. Students struggle to sketch with it because they don't know its affordances. Basically, they don't know what it's capable of.
So how do they fix that?
Yeah.
Zimmerman has this method called matchmaking that I thought was fascinating.
It's a brilliant inversion of the process. Usually design starts with a user problem. My back hurts, design me a chair. But here, Zimmerman flips it. He gives them a capability first. For example, here's the text classifier. It can sort text into categories.
Yeah.
Then he asks, what are 400 things we could do with this?
400 things. That seems excessive.
It's totally intentional.
Yeah.
He forces them to go broad. It's about innovating on the face of possibility.
Uh-huh.
By forcing them to come up with hundreds of ideas, they stop worrying about the math and they start understanding the material. They start to see ML as a creative tool, not just an engineering constraint.
And there are tools making this easier for non-coders, too. I was really interested in Wekinator.
Rebecca Feebring software. This is fantastic for creatives, especially musicians. Instead of writing code to tell the computer, if I do X, play sound Y, you demonstrate it. You wave your hand in a certain way, and you play a sound. You train the system by acting, by moving.
It turns data into a conversation. You're not programming, you're teaching it.
Exactly. And then you have the Delft AI Toolkit from Philip Van Allen. It lets designers simulate AI behaviors, the so-called Wizard of Oz method. You pretend the AI is working to test the experience before you spend months actually building the algorithms. It allows for rapid prototyping of the feeling of the AI.
I want to pivot to what happens when we actually get these interfaces into the world, because the book argues we need radical new interfaces.
Right.
It's not just about making things smoother, it's about making them truly inclusive.
Joanna Pena-Bickley at Amazon is a key voice here.
Yeah.
She talks about being inclusive by design. And she speaks from personal experience. She has dyslexia. For her, voice interfaces like Alexa aren't just a novelty. They untether her from the screen. They make information accessible in a completely new way.
So it's not just checking a box for accessibility. It's designing the system from the ground up to work for different types of brains and bodies.
Yeah.
But then you have some really wild concepts like robot re-embodiment. This one blew my mind a little.
This is another Zimmerman concept. Imagine you check in at a hospital kiosk. That AI personality greets you. Then you start walking down the hall, and that same personality jumps into a small robot guide that leads you to the elevator. Then it jumps in the machine in the doctor's office.
So the ghost follows you from shell to shell.
Right. And in testing, users actually liked the continuity. They felt taken care of. But, and here is the design friction, it crossed social boundaries. People felt that a receptionist robot shouldn't also be the MRI doctor. It just felt wrong.
That is fascinating. We have social hierarchies even for our robots. We don't want the distinct roles to blur.
We do. And that leads to this idea of animistic design. Philip Van Allen suggests maybe we shouldn't have one all-knowing Siri or Alexa. Maybe that's too much authority for one voice. Maybe we should have a zoo of devices.
A zoo.
Heterogeneous multiplicity. Basically, lots of dumb, smart devices with different personalities. One of my favorite examples from the text is the little data wranglers.
Oh, the twins.
Yes. So imagine you're searching for something online. You have a physical device that's the good twin. It adds positive search terms. And right next to it is the bad twin. It adds negative ones. And they argue.
They argue. That sounds chaotic.
It is. But it creates predictive uncertainty. Instead of the computer giving you one true answer, it shows you the complexity. It forces you to think, rather than just accepting the machine's authority.
That's a really cool way to visualize how algorithms work, actually, because they aren't perfect. And speaking of imperfections, we have to talk about the fact that data comes with baggage. The book brings up the work of Alex Fafega and his invisible masks.
This is a really powerful example of design as resistance. We know that facial recognition systems are becoming, well, ubiquitous. Fafega designed a mask that projects infrared light onto the wearer's face.
And we can't see infrared light, right?
No. To you and me, the person just looks like they're wearing a regular mask. But a camera sees that infrared light as a blinding flare. It completely disrupts the facial recognition algorithm.
It's like an invisibility cloak for the digital age.
It is. And it's a design response to a world where we are constantly being watched and categorized. It's saying, I understand how the machine sees, and I'm going to design a way to opt out. It shows that design isn't just about making things easy to use. Sometimes it's about protecting the user from the system itself.
That is such a crucial point. Design is about power dynamic as much as it is about aesthetics.
Absolutely.
So, as we wrap this up, what is the big takeaway? We've gone from salt to dinner parties to arguing robots to infrared masks. Where are we heading?
I think the synthesis here is this transition from seeing these things as tools to seeing them as partners. We are entering an era of co-evolution. The machines are not just prosthetics. They are becoming extensions of the human mind. We're learning from them, and they're learning from us.
The book mentions Anastasia Reina's work, where she uses Jan's generative adversarial networks to create insect architecture. She is using algorithms to generate forms that nature hasn't even seen yet.
It completely blurs the line between the natural and the artificial. It's not just copying nature, it's dreaming with it. And it leaves us with this final provocation from the source material. What does it mean to be inspired by nature when we live in artificial and cyborg landscapes?
That is a heavy question. We're building the very environment that is now shaping us.
We are. And remember, every time you click, every time you interact, you are training these systems. You are shaping the salt that will flavor the future.
So be careful what you click. You're teaching the toddler.
Indeed.
Thanks for diving in with us. We will catch you on the next one.